Yes, sir. So I think now we can start.
All right. So, welcome everyone. My name is Gaurav, and I'll be taking this NRC batch. Okay, let me introduce myself before going further. Uh, I'm having around 20 plus years of experience into network design, deployment, implementation, as well as troubleshooting. And from training experience, I can tell you, yes, around close to more than 5 years now. And I'm triple CCI certified in enterprise infrastructure, service provider, and DevNet. Okay, and uh, NRC course that I'm going to take. I mean, before that, I've taken the NCore as well. Okay, so my primary domain skills are enterprise routing and switching, as well as service provider. Automation is also another thing that I enjoy to work upon. Okay, this is all about myself. Uh, Let me share my screen. I'll walk you through about the course as well as the methodology that we are gonna take. I hope my screen is visible to you guys.
Yeah, Gaurav.
Okay, so NRC is one of the specialized uh, uh, exam that helps us to achieve CCNP enterprise certification. Okay, there is one core exam that is known as NCore, and NRC is one of the specialist exam, right? So this stands for Enterprise Advanced Routing and Services, because people sometimes confuse it with switching, but let me clarify, it is Cisco Enterprise Advanced Routing and Services. So all the topics that are there in the NRC course, they are primarily focused around routing and the services around the network services that we have, right? So exam, if I talk about the exam, it is 90 minutes written exam, which includes your multiple choice questions as well as some of the lablets also. Now, these days they are coming. Okay, the current version number that is Cisco has published, that is version 1.1, and exam code that Cisco has given, it is 300-410. Okay, so okay, moving further. This complete course of NRC, it has been divided into four different domains. Okay, one is first one, which is predominantly there around 35% of the entire course. It is around layer 3 technologies. In this layer 3 technologies, we will cover OSPF, EIGRP, BGP, I mean, all those routing protocol related things. Then VPN technologies, okay, which is again, I think around, it is, yeah, 20% of the stuff, the entire course, it is about VPN technologies, which will cover your MPLS layer 3 VPN, MPLS LDV operations, and DM VPN as well. Okay, point to point, multi-point GRE tunneling, etc. Then 20% is about our infrastructure security, how to secure your infrastructure devices, might be AAA services, IP access list, how to apply control plane policing, all those stuff. Okay, and then finally, the last section is about infrastructure services, which is 25% of the entire course. Okay, wherein I show you the details. Okay, yeah. In layer 3 technologies, as I told you, will be comprising of the tools, features involved around any of your routing protocols, like administrative distance, route maps, how to manipulate your routing information, your control plane information, how to filter them, how to put the tags onto them. Then similarly, how to apply the loop prevention mechanism, what are the best practices around that. Okay, so that is being covered in the loop prevention. Then redistribution between one protocol to another protocol. How can you redistribute your control plane information? Okay, then EIGRP is one of the routing protocol that is part of our syllabus. Okay, EIGRP, IPv4 as well as IPv6, both are covered. Earlier in version 1.0, only IPv4 was there, but now IPv4 and IPv6 both are there. Okay, named mode as well as the classic mode. Both concepts are there. Okay, then different kind of load balancing. I mean, entire since this is you might have known that in core also we have EIGRP covered. Okay, but this is an advanced level thing. I mean, it is expected that anybody who is joining the NRC course, he must have a basic knowledge of EIGRP. However, in how networkings cover it, how I cover it, I assume that even if a person does not have a basic level of knowledge, he'll be able to get that within our course curriculum. Okay, then load balancing, equal cost, unequal cost, how metrics are calculated, how we can tune them in order to influence our actual data plane path. Okay, that is being covered. Similarly, for your OSPF also, all the address families, IPv4, IPv6, both of them are covered. Okay, then how neighbor establishment is done within OSPF, what are different stages, what does the mean, how to troubleshoot them. Similarly, different network types, interface types that we have for OSPF specifically, what does the mean and what are the difference between them. If you remember in NCore, we were restricted to only point-to-point and broadcast. However, in NRC, it is since it's an advanced routing, so we will be covering all the 5 different network types. Similarly, area types also, backbone, normal, transit, stub, NSSA, how they are different, how the behavior changes in order if I change any of the area. Okay, so that all will be covered. It's not only theory, everything will be practical. Almost 95-98% of the things within our NRC you'll be able to do the hands-on within our labs. Okay, similarly, the router types, internal router, backbone, ABR, ASBR, all these are concepts, but yes, in the labs also you will be able to see them. Okay, then comes our BGP. In our NCore, it was restricted to eBGP only. However, in NRC, we'll be covering eBGP as well as iBGP. All these concepts around route reflectors, how to apply the policies, inbound, outbound filtering, how to manipulate the path, okay, how path preference is there, how BGP selects a best path, okay, what is that algorithm, how it works, everything will be covered over here. One another thing I would like to highlight over here, VRF Lite implementation is also part of NRC now as version 1.1. Okay, it was not there earlier. Okay. Any questions so far? This is predominantly what we have in our first section. Okay, next section talks about your VPN technologies, MPLS VPNs, and DM VPN configuration. These both things are covered over here. Just one thing I would like to highlight over here. Within MPLS, MPLS is the data plane technology basically. Okay, LDP, what we use, this is a protocol. Okay, in order for your control plane. However, MPLS is your data plane. Now, within this one, it is only talking about layer 3 VPNs. Okay, at the same time, MPLS can provide layer 2 VPNs, point to point as well as point to multi-point, but that are not part of NRC. Layer 3 VPNs, yes, it is very detailed. Okay, from Cisco prescribed course, what they have published or what they expect from a person within the exam, only theoretical knowledge of MPLS. But yes, within our course, we definitely cover the hands-on as well. We'll be showing you each and everything, how your data plane, your control plane is being established, how your LDP peering is being established over that, how your labels are being sent within your data plane, how labels are getting exchanged, everything will be covered in detail. Okay, similarly DM VPN, yes, it talks about configure and verify. So here it comes the configuration and verification. In terms of MPLS, it was just a description. Okay, if you see the course curriculum also from Cisco, what they have published, they say describe MPLS operations or describe MPLS layer 3 VPN. Okay, so I mean, from Cisco point of view, they expect a person should have a theoretical knowledge. They won't expect to give you any lablets or show command outputs to verify. No. Okay, moving further, the third section, which is infrastructure security. 20% of the exam content. Primarily it talks about your device security, your data plane security, how you can use ACLs, how you can use SSS within your device. Okay, control plane security, control plane policing that you can apply, and IPv6 security. This IPv6 security, few concepts are there. These are again, I mean, from Cisco perspective, this is a person should have a theoretical knowledge. Okay, and these all are configured on your layer 2 switches. They are not configured on your layer 3 routers. Okay, we'll be seeing them in the lab also. The last one, fourth section, which talks about infrastructure services. It is 25% of the exam content. How to manage your devices, how to configure your devices in order to manage them, how to enable the telnet, how to enable HTTP, HTTPS, SSH enablement, okay, secure copy, then FTP and TFTP services, how to enable your devices to do that. Okay, maybe sometimes you have to upload the new iOS image on your device. So how you can do it by configuring your FTP or SCP services. Okay, then monitoring part, SNMP as a network management protocol, couple of versions, V2C and V3. These are the two main ones that you will see in the production networks nowadays. SNMP version 1, and it is almost end of life. Nobody uses that right now. Okay, so the both will be covered, configuration as well as troubleshooting. How to enable the logging services, syslog enablement, local logging as well as remote syslog server logging. Okay, how to enable debugs, conditional as well as simple debugs, timestamps, and telemetry. So this is all that we have. There is a section, I mean, it is part of the fourth one itself, which covers a couple of more topics like DHCP services, IPv4 and IPv6, how to enable them, both of them. Okay, and then IPSLA, what is their purpose, how to configure them, what are their use cases. Okay, then NetFlow, simple NetFlow as well as flexible NetFlow, both are being covered. And the last section is talks about your Cisco Catalyst Center, which is DNAC, how to troubleshoot your network problems within Cisco Catalyst Center. Sure. So this is all about your course curriculum. Okay, but I would encourage each one of you to please remain attentive in the entire course. Hands-on practice, it is must. If you want to learn something, that is must. Okay, because since you all are enrolling for a live course, okay, and live classroom course, it's not a pre-recorded one. So unless until you attend the classes, you ask the questions, you remain attentive, you put on your effort to practice a lot, you won't gain the benefit out of it. Okay, so this is all regarding the course content. You will be getting the slides from our side. Okay, all the pre-recorded sessions will also be shared with you. Whatever we'll be taking all the classes, they'll be recorded. Anybody have any questions so far?
Yeah, good morning, sir. Prasun this side.
Good morning, Prasun.
Sir, in security section, you have mentioned that you are going to cover ACL. So apart from ACL, are you going to cover prefix list and route map as well?
1 minute, let me verify. Prefix list, it is not in the security section, but yes, in BGP, while configuring the policies or while configuring, I'll show you here. If you see, okay, applying inbound and outbound filtering, yes, here we'll be covering the prefix list as well as route maps. So I hope you will be able to get what do we mean by a route map, what is prefix list, how to use them.
Okay, sir. Okay, thank you.
Anybody else? Okay. If no questions, then let me talk few things about how we generally, or I prefer to take my classes. Okay, there are, I mean, several things that I use. Predominantly, I will be doing the whiteboarding. EVNG, will be the software that I used to show you the hands-on. Okay, then PowerPoint slides, yes, we will have. Okay, but I rarely bring them in my classes, because this is something which you will be getting them. You can go through them. There is a lot of material that it is already available. Okay, more and more whiteboarding. I mean, brainstorming how it is behaving. If I change this thing, what will be the behavior change? I mean, mostly it will be whiteboarding and hands-on labs that I'll be showing you. I'll be demonstrating all the labs. The same labs you will also get in the rack. Okay, you can power them on anytime, 24/7. You'll be getting the lab access also, and you can practice yourself. If you get any questions, I mean, if you are facing any difficulty, you can note down, you can ask me and the class. Okay, anytime. Uh, Before the class also, and at the end of the class also, we usually take the question section. I mean, if you have any previous questions, you can take them. Okay, I'll be annotating using the Zoom feature itself. Okay, that's how I take. Now the floor is open for you. You can ask whatever questions or queries you have in your mind. Are you guys, I mean, I'm expecting that you guys are already at least at CCNA level. You have gone through the training of CCNA, or if you have, you are already certified, that is also better. But at least you are well versed with the basic networking knowledge. That's what I'm expecting as a prerequisite.
Pushpin here. So that was my question. Like, I don't have much knowledge on networking,
Mhm.
and I didn't completed any CCNA.
Okay.
My background is on databases. So yeah, because I was looking for CCNP directly.
Mhm. Okay.
So, and I came to know about your institute, and then they scheduled this call. So I think
Mhm.
so my prerequisite doesn't match.
Okay.
So yeah,
So
so maybe yeah. So
push
is there a way where I can continue with this?
Pushpendra, thanks for highlighting this point. Uh, since you do not have a networking background, because there will be
That's right.
why I'm saying so is there will be certain concepts. For example, let's say I'll talk about IP addressing or subnetting. Okay, although it's a plain mathematics. Okay, but uh, it isn't part of CCNA itself. We won't be able to cover within CCNP course. So what I can advise you, Pushpendra, is if you can go through some of the CCNA recordings or go through some of the books and make at least your basic concepts clear, then you won't face difficulty in understanding whatever we are going through. But otherwise, I mean, if you straight away jump onto directly NRC classes, you may face difficulty. You will have to put extra effort for that thing. That's for sure. I'm being honest with you that you will have to put an extra effort. Does that make sense, Pushpendra?
Yeah, that makes sense. So maybe I will touch base with the instructor, I mean the coordinator. So if they can provide me the recorded session for CCNA or
Yeah,
basics.
that will be really helpful. I mean, if
Yeah.
you can get that, it will be helpful.
Hello, sir. This is Khan.
Yes, Ajit.
Khan, sir, sorry, sir, I didn't complete my CCNA now. Like, we have till mid of December.
Mhm.
Like, we covered many things, yeah. So, Ethernet channel, FHR, QoS, BGP, like a basic VPN and the thing. Do you recommend that I should go for it or I should wait it because
Have you
it's
covered IP addressing and subnetting?
yes, IPv4, IPv6, yes, we did it this year.
Okay. You know the basic, what is router, what is switch, what is hub,
Yes,
what
sir,
is,
we did
okay.
it too much, yes. So
You know, I mean, what is a broadcast domain, what is a collision domain? What is a VLAN?
Yes, sir.
Okay.
Yes, sir. Dynamic routing, RSTP, STP, this kind of thing. We cover this all.
That's enough. That's enough. Just
Okay.
brush up all those concepts.
Yes, so we will take it like today, like the Austrian Standard Time. We are doing this like this will go for next 4 weeks. So
Oh, that's fine.
I'm
Yeah, that's fine.
okay. Okay, thank you,
That's
sir.
fine. And have you enrolled in the weekend classes or the weekday classes?
No weekend classes, yes.
Weekend classes. Okay, no worries.
No,
No worries.
but
That's fine.
I don't know where with the time where I am now located is too early, but I don't know if it's like I thought maybe I don't have the possibility to take with you. That's why I joined yesterday.
So
So
you are based out in Australia region?
no, I'm first in Austria, Europe, CET, Central European
Okay.
time.
Oh, okay, okay. It's too early for you, huh?
It's too early, yes. It doesn't matter, it's just a weekend, yes. We have Saturday, Sunday classes.
Yes, we'll be have a class on Saturday and Sunday, 10 a.m. Indian Standard Time.
Okay.
Okay. The class usually it takes around at least 2 hours, but sometimes based on the topic, it goes up to 3 hours also. Because
Okay.
sometimes discussion is going on, we don't want to drop it or break it into the two different classes. So it goes up to 3 hours also. I'm being transparent with you guys. So
Okay.
please book your time accordingly.
No, so there's no problem. We have the like CCNA. This is like Indian Standard Time, 8:30 now. So it will be no problem.
Okay.
But I just want to confirm if it's like the time that I can go for CCNP or I should wait next 1 month and then I can join. But as you said that I can do it, so no
You will be
problem.
able to do it. Yeah. I mean,
Okay.
whatever topics that you have told,
Yes.
I am sure you will be able to definitely do it.
Yes, we did it like we have now the VLAN, like we did it BGP, but we just, let's say we just did the basic, yes, with CCNA, you just do it the basic, and so let's see, yes.
Yeah, CCNA actually it's a associate level course. So definitely it is expected that to cover the advanced things, you will be joining the CCNP professional level course. So that is expected. Yeah, that's fine.
Thank you, sir. Thank you.
Anybody else having any questions?
So when is the class starting?
Sorry. Sorry, say again, please.
When is the classes starting for CCNB?
Today only, guys. Like this is the reason we are asking. Like you ask what are the doubts related to the course curriculum and all, and now after that we are starting the session.
Yeah, it will be from today only. Same call that we are joined in. We'll continue this. The last batch that I took, all the candidates, all the students, they were very much active. I mean, and they keep on asking me more and more questions. Even I'll have to sometimes say them that, wait a minute, let me reconfirm this concept. So I want to encourage each one of you to please ask questions, be attentive. Okay, it is beneficial for all of us, because let's say one person is asking some question or a doubt, the rest all will be able to gain something from it.
Question.
Yes, please.
My question is regarding documentation. There is so much documentation about Cisco devices, and I was wondering if there will be like some type of tricks and tips about being efficient at looking up like information about Cisco devices especially on their website.
If I repeat your question, I think you are asking about how to be efficient in looking some topic on Cisco website, some tips and tricks around that. Is that your question?
Yeah, going through like the documentation on Cisco website, because sometimes one can get lost into the amount of information that
I
so
absolutely agree with you. I mean, Cisco is one of the provider whose documentation is a lot. I mean, per device, per model, per iOS version, they have the complete separate documentation. No problem. I can navigate that. I can help you that. Okay, please remember this thing and remind me during our classes. I can help you navigating through the Cisco documentation also.
all right, thank you.
Yeah. But yes, I mean, I agree that it is so. And majority of the time nowadays, people, what they do is they open ChatGPT and ask questions to him. But I won't suggest using ChatGPT because you never know. I mean, there are so many hallucination things also. ChatGPT gives you an answer in a confident way, and maybe who knows, it could be a wrong answer also.
Yeah, I think it's better to have a second source to
Correct.
verify
Yeah.
that kind of information. Yeah.
Yeah, verified source, correct. I mean, something which Cisco is publishing, we can rely on to it rather than going to the Chat GPT or Google. Yes, guys. So if I ask you, how many of you have gone through Encore?
Hello.
Yes.
Hi, sir. This is Satish Sharma. I joined your previous core class.
Oh, yeah, Satish, I remember. Yes, yes. I can recognize your voice. Thank you. Thank you, Satish.
Yeah, I'm waiting for your NRC classes.
Okay.
From
Thank
the
you.
last one. I asked
Thank
them
you.
multiple times when Gaurav sir is going to start the NRC.
Okay. Thank you. Thank you, man.
I enjoyed your previous batch a lot. That's why I asked them to join Gaurav sir NRC classes.
So nice of you. Thank you.
Yeah, thank you.
Anybody else also from our previous batch? New names are there. Navya Rastug, were you there in any of the previous batch?
No, sir. I think she's from my team only.
Okay. She's from your team. Okay, fine. Anybody else having any other question, or can we start then? Okay. If no question, then let's begin. And one last thing, guys. I know Hindi, I know English. Okay, and little bit of Punjabi also. So don't I mean, restrict yourself in whatever language you guys are comfortable. You can ask me the questions. Okay, if you are not comfortable in English, you can ask me in Hindi and Punjabi also. Okay, so don't feel ashamed, but please clarify your doubts.
We have class tomorrow as well.
Yes.
Same time.
We'll have same time.
Sir, I am Marathi, so that you can speak in English or Hindi. I can't understand Punjabi.
Okay, yeah, Kalyani. I mean, it was not for me. Even I could not speak Punjabi. I was talking about if somebody is from Punjab and he is facing difficulty in asking question in English or Hindi, at least I will be able to understand and I can translate that. Marathi, I don't know. I'm so sorry.
No problem.
So we will stay in Hindi and English because I know like I don't know, but I speak like Urdu, yes, and I think it's the same when I speak, so I think it's the same. So I hope you understand when I speak in Hindi. So
Yeah, I'll be able to say it. No worries.
thank-
Okay, guys. So let's start from some of the basics. Okay. So I'll be asking you some of the questions. I mean, whatever best you know, please share. What is a collision domain? Anybody?
uh, sir, a network segment where the packet can collide multiple devices to transmit uh, oh, the same time, I believe.
Okay. At the same time, if multiple devices try to send the packets and they collide, that becomes a single collision domain. If I think through, let's say this is your switch. I have different interfaces or ports. 3, 4, and let's say 8. Total 8 ports. How many collision domains does they have? Guys, please participate. Anybody? Okay, no worries. So in switch, each port is having its own collision domain. So there are 8 collision domains.
Sir, the screen is not visible to me.
Is it so?
The whiteboard.
Whatever I am annotating, is it not visible to any of you?
No, it's visible.
Yes.
You can log out and log in again.
Okay, thank you. I'm just saying the display from Navi Rostogi, so I will try. Thank you.
Okay, maybe you can retry. So guys, each port is part of its own collision domain. So 8 different collision domains. If we assume these are 8 different ports. At the same time, if you think that this is not a switch, it is a hub. What does that mean? Same number of ports. Let's say 4, and then delete one of them. So what do you think? How many collision domains do we have in this hub? Okay. In hub, if we differentiate between switch and a hub, all the ports are part of one single collision domain. That means if let's say one PC is connected over here, another PC is connected over here, they both cannot send at the same time. PC1, PC2, and let's say PC3 also. At one single timestamp, at one single instance, only one of them will be able to send or receive the packet, because otherwise they'll collide. But in case of switch, let's say this PC, PC1 talking to PC2, here it is PC3, PC1 and PC2, they are talking to each other. At the same time, PC3 and PC4, they can also talk to each other, because each port is a separate collision domain. Okay, if somebody asks you, please help me differentiate between a switch and a hub, that's how you can explain him. So what do you think, which one is better? which one is more efficient? Guys, am I audible?
Sir, switch is more efficient.
Switch will be more efficient because each port can communicate independently. It's not waiting that I should get a free channel. Okay, now at the same time, if I talk about this broadcast domain, what do we mean by one single broadcast domain? We are connected through a Zoom call, right? Everybody has been connected to the same meeting invite link. If I am speaking something, all of you can hear me, isn't it? So I'm basically, the messages that I'm sending, they are being broadcasted to all of you, who all are part of this one single Zoom meeting, isn't it? So this becomes a one single broadcast domain. Does that make sense? Similarly, in your switch or your hub, if I send something, I send a broadcast packet, it can be sent to all the other ports by default. By default, all the ports, you must be knowing that they are part of VLAN 1. That is nothing but your broadcast domain. If I send a broadcast packet, it will be sent to all the ports. So this is switch will be having one broadcast domain, which is equivalent to one VLAN. I'm talking about unmanaged switch. One is unmanaged switch, one is managed switch. Can anyone tell me what is the difference between these two? Unmanaged versus managed. Simple difference, the one which you can configure. That is a managed switch.
Sir, we have L3 managed switch or layer 3, yes?
Okay, you are talking about layer 3 versus layer 2 switch. Okay,
Yes.
I'll come to this point. I'll come to this point. Just wait. Okay, managed versus unmanaged means a managed switch, you will be able to configure it. You will be able to log into it, maybe put some host name, put some IP address, configure some VLANs, configure the individual ports, check the STP status and all that. That is your managed switch. Certain switches which are unmanaged, 8 port, 24 port, many of them comes in the market, which you cannot configure at all. Okay, all the ports will be part of one single broadcast domain. That's it. Nothing else. You won't be able to configure them. Those are known as unmanaged switch. Right? Now, talking about layer 2 versus layer 3. Before coming to this, I'll come to this point. Wait a minute. Let me please first clarify what do we mean by layer 2 versus layer 3. Assume there is a switch. Okay. There is a PC connected over here, and there is another PC connected over here. IP address, for example, 10.1.1.1/24. 10.1.1.2/24. Now, first question is, will they be able to communicate with each other? Assume this is unmanaged switch.
Yes.
Okay. Will this communication will be layer 2 communication or layer 3 communication?
Layer 2.
Okay. You said layer 2 communication. Does everybody agree or somebody have any doubt? It is layer 2.
Hi, Gaurav sir. I think it will not communicate because they are seems in different network.
No, they are
And,
in same. They are in same network. 10.1.1/24.
okay, okay.
10.1.12/24.
Okay, in this case, they will be able to communicate.
They will be able to communicate. Okay. Now the next question was, is it a layer 2 communication or layer 3 communication? So one of our
Layer 2.
Layer 2.
Layer
Why
2
did you?
communication.
Okay. Why do you think it is a layer 2? What is the reason?
Because it completely works depend upon MAC address communication only.
Very nice, Sunil. You are saying the communication is happening based on the MAC address. Correct? If we double click this thing, if we double click, okay, this PC, let's say you type this command ping on your C prompt and you say 10.1.1.2. What it is going to generate? It is going to generate some ICMP messages. Correct?
Yes.
So this ICMP message will be encapsulated in your IP header. I will have source IP and destination IP. Source IP is 10.1.1.1. Destination IP is 10.1.1.2. Correct?
Yes.
Okay. This is my packet. OSI layer, open standard interconnect. This is your layer 3 packet. Correct? Now, this packet has to go out on an Ethernet interface. So there must be some layer 2 header. In layer 2, we will have a source MAC and destination MAC. Correct? Source MAC, assume it is AA. Destination MAC, for example, it is BB. So I will have source MAC over here. Do I know the destination MAC? I just fired this command ping 10.1.1.2.
No, not no.
We will not have. Initially, this PC1 does not have. Correct? But in order to create this layer 2 frame, I must have this field. I'll have to populate this field. Right? So what this PC will do, if he wants to know the MAC address associated with this destination IP, how will I know that?
Then an ARP request.
ARP request. So there is a protocol that is known as ARP, which is Address Resolution Protocol. Okay, which is used to convert your IP to a MAC. Or rather, conversion, I would say, map your IP with a MAC address. He'll generate an ARP request. That ARP request is a broadcast request. It will be sent over here. Then here, PC2 will reply or send a response back with its own MAC address that yes, I am 10.1.1.2 and this is my physical MAC address. Now he'll come to know. Okay, one question. Where will I, at PC1, where this MAC address and IP address are getting to be stored?
ARP table.
I will maintain an ARP table in which I will store against this IP, there is a MAC address. Okay. After populating this in your ARP table, then I'll be able to create this frame. Now this becomes your layer 2 frame. Since within your layer 2 frame, you have your source MAC and your end destination MAC also. So any of the in-between devices that is coming, maybe one switch, two switch, or any number of switches that are coming, they are only switching the packet seeing this MAC address, destination MAC address. Okay. If I assume that this is your managed switch. So if it is a managed switch, I'll be having a MAC table. In MAC table, I will have port, associated MAC, and the respective VLAN. I assume that every port is in VLAN 1. This is port 1, this is port 2. On port 1, I have reachability to AA. On port 2, I will have reachability to BB. Any doubt in this MAC table content? No? Okay. So when this frame is being sent to the switch, what this switch is doing? This switch can understand a layer 2 frame. That's why we say that switch works at layer 2. Isn't it? So switch is only seeing the outer header, which is my layer 2 header. And from that, I'm only checking the destination MAC address. I will match that destination MAC address with my MAC table. And the switch will come to know, in order to send any traffic for this destination, I should send it out via port number 2. That's it. Exactly same Ethernet frame, the switch is going to copy and send it to port number 2 as it is. I'm not changing anything into my entire frame. As a switch, he has not manipulated or not modified anything in your entire frame. So at the end, the switch is only taking the action based on the original layer 2 frame. And the original layer 2 frame is being sent from port 1 to port 2. That is why this communication is known as layer 2 communication. Any questions? Can I erase this board? Okay. I'll take it as yes. Now, assume that which one? Router. Which two? One PC is connected over here. One PC is connected over here. 10, 1, 1, 1, 24. Assume this is 10, 2, 2, 2, 24. This interface having IP 10.1.1.254. This interface having IP 10.2.2.254. That's 24. Purely layer 2 switch. Layer 2. Now again the same question. PC1 to PC2. Will they be able to communicate? Gateway is configured as Guys, will there be any communication between PC1 and PC2?
We need to do routing on router 1.
Okay. What kind of routing you want over here?
Or we can do
Assume,
that static.
okay. Assume routing is already there.
Yes,
Routing is
so they
already there.
can able to communicate.
They can communicate. Correct? What kind of communication it is?
Layer 3.
Layer 3.
Layer 3. Why you said it is layer 3?
Because router is involved in it and the routing is there. So we.
Okay. In other words,
Also, we have a gateway also.
We have a gateway also. Very nice. Okay. This subnet and this subnet. My source subnet and my destination subnet. They are different. In the previous scenario, where your PC1 and PC2, they are connected via same switch. PC1, PC2, 10.1.1/24, 10.1.1.2/24. They were in same subnet.
Yes,
And you said it is layer 2 communication. This is layer 3 communication. So in other words, we can say intra-subnet communication is layer 2 and inter-subnet communication is layer 3. Anytime you want two different subnets to communicate with each other, that is a layer 3 communication. For that, you need a layer 3 device. Your router is a layer 3 device. Your switch is a layer 2 device. Does that make sense? Layer 2 communication versus layer 3 communication. Intra-subnet, inter-subnet. Guys, for example, this subnet 10.1.1.0/24. You remember in CCNA, you might have done that first usable IP, last usable IP, broadcast IP from this subnet. I hope you might have done this kind of questions. So first usable IP of this subnet will be this one. Last usable IP of this subnet will be this one. Broadcast IP will be this one. Correct? Yes or no?
Yes, correct.
Yes.
Okay. So we are saying within the subnet, it is intra-subnet. Okay. If he sends a broadcast message and all these PCs are connected over here, will they receive this broadcast message or not? If I send a ping to 10.1.1.255, this is a broadcast address. Will everyone receive that message or not? Let's say some other PCs are also connected.
Yes, sir. As long as it's broadcast, it will go.
And they are part of same VLAN also at layer 2 level. They must be part of same VLAN. All these ports. When we talk about VLAN, that is at switch level. Can you configure a VLAN on a PC? No. You can't configure. A VLAN will be configured at a switch level. So one subnet is equal to one broadcast domain is equal to one VLAN. That's what we saw. Is that clear? Inter subnet, two different broadcast domain. This is one broadcast domain. This is another broadcast domain. This IP and this IP, they are part of same subnet. They are part of same broadcast domain. If I want to communicate between two different broadcast domains or two different subnets, that is a layer 3 communication. Any questions? Guys, is it making sense to you? Yes, no, maybe.
Yes, sir. It's clear.
Yes, sir. Yes.
Clear? Okay. Let's take another example. Again, same diagram. R1, switch 1, switch 2, PC1, PC2, 24. Assume this is .254. This is 254. 10.1.1. Sorry, 2.2.2/24. MAC address AA. BB. Interface will have a MAC address, let's say CCC. Interface, let's say, have a MAC address DD. Port number 1, port number 2. Port number 1, port number 2. Now guys, tell me one thing. Which I have 5 devices over here. 2 PCs, 2 switch, 1 router. Where will I we have spoken about ARP table. We have spoken about MAC table. And okay, let's restrict ourselves to these 2 tables. Which device will have ARP table? Which device will have MAC table? PC1, will it have MAC table?
No, we have ARP table in router and PC.
Yes, ARP table good.
ARP table. Okay, here also I will have ARP. At router also I will have ARP table. Correct? At switch level, it's a layer 2 switch. I will maintain a
MAC table.
MAC table. So wherever you have an IP address, okay, that is going to maintain your ARP table. Which is not having an IP address, that is going to maintain your MAC table. Switches where we do not have a IP address. So far, I'm considering this as a layer 2. That is the reason it is only maintaining your MAC table. If I make it layer 3, if I configure IP address over here, it will become a layer 3 switch. It will start maintaining a layer 3 ARP table also. Okay. Now let's populate the MAC table of switch 1. I will have port, I will have MAC address, and assume same VLAN. Port 1 and port 2. Assume that there are only 2 ports. 2-port switch is nothing but a bridge. Guys, a 2-port switch, you might have heard this term, is known as bridge. The difference between bridge and a switch is bridge is a 2-port switch. That's it. On first port, which MAC address will I have? Port number 1.
AA.
Port number 2.
CC.
Anything else? Assume part of VLAN 1 only. Will I have any other entry? Can I learn these MAC addresses at switch 1? Guys, yes, no, maybe. Any thoughts? Can I have any other MAC address from here in this switch MAC address table?
I think router interface MAC also need to.
Router interface MAC CC, you have put it over here. Do you think the other interface MAC will also come over here?
No.
No.
It won't come.
So another concept that you have learned, the MAC table is being maintained per broadcast domain, not out of your broadcast domain. My switch is maintaining VLAN 1, which is one broadcast domain. So I will keep entries only from that broadcast domain. If I have another port which is part of VLAN 10, yes, I'll maintain then that entry also, which is part of VLAN 10. But not from other broadcast domain, which is not connected to the switch at all. So another concept that we have learned, the MAC table is being maintained per broadcast domain. Hey, Deepika, what are you doing? How come my own voice is coming? Okay, thanks for muting. Okay, same way. At the same time, I will have a MAC table over here also on switch 2. Guys, quickly tell me what is there at port number 1, port number 2.
Port number 1 BBB.
BBB. Port number 2.
And port 2 DD.
Right? Assume VLAN 1 only. Okay. ARP table of PC2. I have, let's say, IP to MAC entry. I have my own, which is BB, and I have 254, which is DD. Correct? My gateway's MAC should be there in my ARP table. Do you agree? How you are going to learn this gateway MAC? Guys, you know the answer. How ARP table is being populated? ARP protocol. On this PC, I will have my own IP address, own MAC address. Gateway MAC. Correct? These are the contents that I have. So far, so good.
Yes.
Okay. Now, let's say from PC1, you send a ping message 10.2.2.2. What will happen? I'll create a frame, sorry, ICMP payload, source IP 10.1.1.1, destination IP 10.2.2.2. Correct? I need to send it out via Ethernet interface. So I must have a layer 2 header. In layer 2 header, my source MAC, AA. What will be the destination MAC?
Gateway MAC.
Okay. Why it is gateway MAC? Why not this MAC? BBB.
We are going to different network address.
Correct. Okay. So PC1 is intelligent enough. He has its own IP address. He has its own mask. If you have noticed sometimes, let's say I'm using a Windows machine. In Windows machine, in your network connection settings, you are going to configure an IP address. IP, mask, and gateway. 3 things are there when you configure, and DNS entries also, name server IPs, DNS1, DNS2. Right? Out of these, IP and mask are mandatory. This is optional. If you have not configured your gateway, you won't be able to send your traffic outside your broadcast domain. But if you have configured your gateway, that means your PC can decide himself that the destination IP is not within my own broadcast domain using its own IP and the mask. He can identify This belongs to some other broadcast domain. So I have to send this traffic to my default gateway, which is CC. This decision is happening at the PC level itself. Nobody else is telling your PC that you need to populate the destination MAC address of the gateway. Right? Now this frame is complete. He'll send it out via this interface. This frame reaches to your switch 1. Switch 1 works at your layer 2. It is going to check your destination MAC address. It knows that it is reachable via port number 2. So I will send it out via port number 2. So far, so good. And this frame is going to reach your router 1 interface, let's say E0 by 0. Now, this is a router. And he will check within this layer 2 header. This MAC address is my own MAC address. So he will assume that this frame is destined for myself. I will receive, I will decapsulate that packet, and over here he will remove this layer 2 header, and inside that he will see that there is an IP packet, source address this and destination address this. He has decapsulated or he has removed the layer 2 header. Why? Because this frame was destined to himself. That's why he will remove that and he will try to assess what's there inside that frame. Inside that frame, he'll see, okay, there's an IP header. So I'm a router, I'm a layer 3 device. I'll make my decision based on my routing table. I'll check this network 10.2.2.2. It is reachable via E0 by 1. So I have to send this out via E0 by 1. And being an Ethernet interface, before sending it out, I'll have to put again a layer 3 header on top of it. 10.1.1.1, source IP remains same, destination IP remains same. I again put a layer 2 header. Within this layer 2 header, source MAC will be this one, DD. What will be the destination MAC? Destination MAC will be of this PC, BB. And from where I will find, you remember we spoke about R1 is also going to maintain an ARP table. So I will have an ARP entry for this one in my ARP table. From there, I will populate the MAC address against this destination IP address. I'll create this frame. Frame will be sent out. It will received at switch 2, port number 2. It will check destination MAC address again. Because I'm working at layer 2, I'll check my MAC table. Okay, BB, it is reachable via port number 1. I'll send it out via port number 1. This frame as it is, it will reach at PC2. Destination MAC address, okay, it is for myself only. I'll remove this layer 2 header. Okay, I'll check, okay, IP header. Okay, destination IP, it is myself. I'll remove this destination IP header also. Then comes your ICMP packet, which is your application layer. It will send it to the next layer, ICMP layer, and he will accordingly send a response back. That's how your layer 3 communication happens. Anybody have any questions? In our scenario, we took this as a router. Rather than calling it as a router, I could have called it as a layer 3 switch also. Functionality wise, exactly same. Only difference would have come. Along with ARP table, I will also start maintaining a MAC table. port and MAC. I'll maintain that. Okay, if there would have been any layer 2 port for them, I will also start maintaining a MAC table. Does that answer your question? I think somebody was asking about layer 2 switch versus layer 3 switch.
Yes, sir. Thank you.
Any questions?
Sir,
Yeah.
sir, one question, sir. In this diagram, like in simple diagram, like what kind of changes we can do where, uh, so that the switch will face a MAC flapping kind of situation?
You want to simulate MAC flapping? Huh?
Yes.
This is your ask?
Yes, this is my ask.
MAC flapping. Okay. I can erase this board?
Yes, sir.
What do you understand by MAC flapping? It's a good question, but let's first double click onto it. What is MAC flapping?
What I have read is like whenever multiple MAC address is learned on a same port, that's called MAC flapping.
You said whenever multiple MAC address received on the same port.
Sorry, the single MAC is learned on a multiple port.
Correct. Now you are right. I mean, same MAC address, if you are receiving on two different ports, that causes your MAC flapping.
MAC flapping, yes, sir.
Okay. Think that this is a PC one. Okay, it is having MAC address AA. Port number 1, port number 2. Now, because switch is maintaining a MAC table, I received this MAC address on port number A. If after some time, same MAC address you start receiving on port number 2, what will happen? Switch will remove this entry and keep this entry. Or rather, I can say that I will update my MAC table against this MAC address. I'll put port number 2. Again, after some time, if I start receiving same MAC address on port number 1, I'll remove this entry and put this one. This is basically a MAC flapping. This is the scenario that you are talking. If it is happening at a frequent basis, okay, that may cause an issue because it is consuming your CPU resources of your switch. Every time the MAC is being updated, a switch has to flush the earlier entry. It has to update a new entry in its MAC table.
Yes, sir. Like, I just want to know on which kind of scenarios, or like which kind of faulty scenarios, this kind of flap can happen.
Okay, assume that between PC and a switch you are having a hub, and from this hub you connect it like this. Okay, generally this happens because of malfunctioning. Your hardware level malfunctioning, that's where it happens. Otherwise, it should not happen. I mean, if you are communicating via one port, it should keep on communicating through that port. But if you are putting a hub in between, it may happen that one of the packet is going by this way, another packet is going by this way. You never know. Right?
Yes.
But I mean, first, always try to understand what do we mean by MAC flapping. How it is happening, that will be secondary. Why it is happening, that is secondary. First, understand what is the concept behind it. Root cause may be different. This is just one scenario. There may be multiple other scenarios also. Okay. Any questions so far? No problem. Okay. Now coming back to the same scenario, let me remove that switch. Muhammad Kashif, difference between NCore and NRC. Okay. If I help you understand, NCore is a combination or it is covering all the core technologies, your routing, your switching, your security, your wireless, your infrastructure, automation. Okay. And what else? Yes. I mean, NCore is about whatever tools, the feature set that we have within our enterprise networks, routing, switching, security, wireless, automation. Okay, everything is being covered at a high level. Now, in order to do a double click onto your routing thing, that's why it is advanced enterprise routing and services. Okay, so NRC is the advanced part of your routing and services. NCore was high level and NRC, you can say low level, covering your routing. Similarly, another exam, for SD-WAN, you have a double click. Although SD-WAN is also being covered in NCore, but that just a theoretical part, high level. Then if you go to, I think exam name is ENSTW something like, so that is a double click or a low level of your SD-WAN. Does that help answer your question, Mohammed Kashif?
So sir, here we will learn more about the routing or the switching also.
Routing, purely routing. There won't be any switching over here. Why I covered is because I wanted to differentiate or make you guys understand when we talk about a layer 2 communication and versus when we call it as a layer 3 communication, how they are different. Within a layer 3 communication, how my packets are getting sent and how the structure is getting changed at each broadcast domain. Okay.
For the switch, like in depth one, what we have on the Cisco.
Sorry, Devrata.
For the switch, like we have NFC for the routing, what we have for the switching side also?
No, we do not have any separate exam for switching. Earlier we used to have. Nowadays we do not have. I mean, Cisco has removed that part. Okay, coming back over here. So from the same figure, may redraw. Is there a question? Gateway 254. Gateway 254. Yes, is there a question? Idris, is there a question? Okay, thank you so much. Okay, so in this topology, again, coming back to the same question I asked earlier as well, PC1 to PC2, will they be able to communicate? If yes, then how? If no, then what do we need to do?
It should communicate.
It should communicate. Okay. How?
Because
do we
the
need to
PC
place any routing?
No.
Does everybody agree that we don't need to put any routing? We don't need to configure any routing, to be specific? Do you think we need to configure any routing over here? Routing protocol, static, dynamic, anything?
I think it's not required because the interfaces are directly connected.
Okay, very nice. What does that mean? Interface is let's say E0 by 0, E0 by 1, E0 by 0, E0 by 1 are directly connected. PC is going to maintain ARP table. R1 is going to maintain an ARP table. Correct? It's a layer 3 device. At layer 3, your router is also going to maintain a routing table. Huh? Do you guys agree? Because I'm a router, I'll maintain the routing information in a routing table, also known as RIB, routing information base. Full form stands as routing information base. So how many routing tables does a router have?